Hi, hello. Can anyone confirm whether I'm audible or not? Can someone confirm whether I'm audible? You can type in the chat box. Okay, thanks. So I think this is. I guess the other session is still going on. So maybe we can wait more for some more time. Maybe like 5 minutes. We'll wait for few more minutes. Is that okay? I think the previous session is still going on. Okay, thanks. We'll start in like some 5 minutes. Hello. I think already more than 15 people are here. Maybe we can slowly start. So some initial 5 minutes will be mostly revision. So that should be fine. I think we can start. Okay. So good evening, everyone. My name is Prashop. I'm currently doing my PhD in IIC Bangalore. So every Wednesday during 7 to 8 p.m. So we'll be discussing problems, gate problems from signals and systems, communications, theory, and probability, and some other topics. So during any time, if any of you is finding any difficulty in following the content or any doubts are there, please feel free to not audible. If I'm not audible at any time, please let me know. So shall we start? So shall we start? Okay. So today our focus will be on this particular topic from signals and systems. We'll be discussing about discrete time Fourier transform and discrete Fourier transform. We'll be focusing more on the gate problems than on the theory. So let us begin the session by quickly reviewing what are these things. So let x of n be a discrete time signal. Then The discrete type Fourier transform is defined like this: x omega, which is summation n from minus infinity to infinity, x of n e raised to minus j omega n. Here, the thing is that x of n is a discrete time signal, whereas omega is continuous. That's the only thing. This omega is known as the digital frequency. That's just a name that we used to refer to the omega. And it turns out that this DTFT, discrete time Fourier transform, is periodic with a period 2 pi. Basic idea. Now we can also, so here we have seen how to go to DTFT from the signal. Now we can also come back from the, given that DTFT, what is the signal is. So that is known as the inverse DTFT or IDTFT. So how do we have that? So here x of n is given by 1 upon 2 pi integration from minus pi to pi x omega e raised j omega and d omega. This is how we come back from Fourier domain to the time domain. This is the basic definition. This is how we define the discrete time Fourier transform. Everything's okay. If there is any doubt at any point of time, please let me know. Feel free to interrupt the live session. Okay, so that is how we define DTFT. Now we see what is a DFT. It's a discrete Fourier transform. So what exactly is DFT? Let x of n be a discrete time signal of length n. Now the n point DFT is given by x of k, which is summation n equal to 0 to n minus 1 x of n e raised to minus j 2 pi by n kn. Now here again, just like before, this is the forward equation. Like given what is x of n, how do you get x of k? The point to note here is that this is very similar to that of DTFT, but there's a small difference. Here, this is discrete. For DTFT also, that was discrete. Whereas the second term, it was e raised to minus j omega n for DTFT, whereas it is e raised to minus j 2 pi by n kn here. That means this is also discrete. Or in other words, x of k is discrete. Earlier for DTFT, x of omega was continuous because omega is a continuous function. I mean, omega is continuous. Now, what is the relation between DTFT and DFT? So, DFT is obtained by sampling DTFT at omega equal to 2 pi by n k for k equal to 0 to n minus 1. That is how we get. Sorry. Just as we have the DFT, we can also go back from xk to xn through inverse DFT, and the definition is like this: x of n is given by 1 by n summation over k x of k e raised to plus j 2 pi by n k. That's the IDFT. So these are the basic things, and we'll also see some of the properties of these DTFTs and DFTs. Now, any doubts till now? Shall I proceed?
Yes.
Okay. These are some of the properties. Let xn be the signal time domain. Then x omega be the DTFT and x of k be the DFT. Now, what happens when we give a linear combination of two signals, alpha x1n plus beta x2n? Then the DTFT will be alpha x1 omega plus beta x2 omega, where x1 omega is the DTFT of x1n and x2 omega is the DTFT of x2n. This is the linearity property. Similarly, for DFT, we'll be having alpha x1k plus beta x2k. This is the time shifting property. So if we have x of n giving x of omega, x of n minus n naught will be giving x of omega e raised to minus j omega n naught. And for the case of DFT, it is slightly different. Here we have a time shifting, whereas for DFT, we need to work with signals which have the same length n 0 to n minus 1. So, sorry, we define circular time shift something like this. So, if we circularly shift the signal x by n naught, then the DFT will be x of k e power minus j 2 pi by n k n naught, where this n naught is the time shifting. is the duration by which we have circularly shifted. Similarly, this is time reversal. If you reverse in time domain, frequency domain get reversed. Similarly, for the case of DFT, if you do a circular reversal, the DFT also get reversed circularly. That's it. And this was again the convolution property. So what do we have? X1n convolution x to n. This becomes multiplication in the frequency domain. X1 omega times x2 omega. Similarly, for the DFT, circular convolution becomes multiplication. One small point to have here, what exactly is this circular shifting? So what happens is x of n minus n naught mod n. What this is how we define circular shifting. So how is this working? We are shifting a signal, but we will make sure that the value comes back to the actual place. For example, let us say x of n equal to 1, 2, 3. So x of n minus 1, if you do, let us say this is the origin. If I do x of n minus 1, that will be like 1, 2, 3. But now the support have changed. Earlier it was 0 to 2, now it is like 1 to 3. So that is different. Whereas if you do this circular shifting, what happens is that whatever quantity that is going outside the range, like for example, here original signal was only from this range. This 3 is outside. Whatever is outside, it will come back to the original place. So 1, 2, and 3 comes here. This is how we do circular shifting. This is fine, no? Any doubts?
Can you please repeat the topic regarding?
Yeah. Sorry. Explained here is the difference between the usual shifting and the circular shifting property. Now, if we have a signal like 1, 2, 3, where this is time index n equal to 0, 1, and 2, if I just do a normal shifting x of n minus 1, everything gets delayed by 1, something like this. This is the usual shifting. Now, the thing with usual shifting is that if the original signal is from 0 to 2, the shifted signal is from 1 to 3. So the support where the signal is non-zero will be changed. Now, we can also define shifting in a different way. How is that done? That is known as a circular shifting. So we denote the circular shifting like this: x of n minus n naught mod 3. This is of length 3, and I am shifting it by the value n0. This is the definition. This is the way in which we represent circular shifting. And what happens in circular shifting? It is just like normal shifting. Only thing is that whichever number that is going outside the actual range will come back in a circular fashion. So we can think of it like a, so here we can think this is a strip of paper and we are just pushing it to the right. Whereas here for circular shifting, we have a strip of paper where the last end is connected to the beginning, and we are just pushing it to the right. If we want to shift it to one to the right, we have 1 comes here, 2 comes here, and 3 goes here. But since this will come back here, this is circular shifting. Is it okay?
Yes, sir.
Okay. Hello.
Yes, sir. Thank you. Yes.
Okay. Thanks. So these are the basic things, and now there is one more thing. So any other questions? Any other doubt? So the circular shifting is very important. Like all the properties, most of them with the DFT, we will be needing this definition of circular shifting. So even though this looks a bit complicated, the operation is very simple. Think that the last and first are connected. Shift it. Assuming the this one comes back here, we can just rotate. That's how we define the circular shifting. Any other question? Shall I continue?
Yes, sir.
Okay, thanks. So now this is a So this DFT and IDFT, these operations we can think in terms of matrix multiplications. So how is that? Let x of n, this is a vector by the way. This, let us define this vector as x of 0, x of 1 up to x of n minus 1. This is my signal. This x of n. And basically, so basically we'll be having x of 0, x of 1 up to x of n minus 1, right? That's it. This thing I am collecting in a vector and I am calling it x of n like this. So this is my signal in time domain. Now, okay, so x of 0 up to x of n minus 1 we have. I take the DFT. I'll be having x of 0 up to x of n minus 1. Now, let us collect this DFTs in another vector. Let us call it x of k. X of 0 up to x of n minus 1. So once again, this is my time domain signal, where this is like the time index. This is my frequency domain signal, where this is like the frequency index. Just like this. Now, we can write this x of k in terms of x of n in the form of a matrix multiplication. How do we do that? We have x of k to be this big matrix times x of n, where this matrix is like this. First row will be 1, 1, all ones. Second row will be 1, wn raised to minus 1 up to wn raised to minus n minus 1. Similarly, the last row will be 1, wn raised to minus n minus 1. Finally, wn raised to minus n minus 1 whole square. Whereas this wn is defined like e raised to j 2 pi by n. Now, this is very simple. Like what we did is we just returned the DFT. We, if you see here, this first row times this vector, that will be x of 0. It's easy to verify that. We right now we have times constraints, so we are not doing that, but it's very easy to do that. Similarly, this row times this vector will be nothing but x of 1, like that. So in short, the relation between x of k, the DFT, and x of n, the actual signal, can be written like x of k to be a matrix times the signal x of n, where this matrix, let us call this F, is known as the DFT matrix. This is how we represent the DFT operation as a matrix multiplication. So any doubts or any clarification here? It's easy to verify that this is true. So say standard fact. Any doubts? Shall we continue?
Yes.
Okay. So what do we have here? X of n is my time domain signal. The DFT is obtained by F times X of n, where this F is a DFT matrix. And this F is again square matrix, and it is also symmetric. I mean Hermitian basically. So yeah. Now, what next? Yeah. How do we go back from xn from xk? So we have the IDFT. So what is IDFT? X of n is given by 1 by n F Hermitian x of k. So these are the two properties that are interesting. This is the DFT. This is the inverse DFT, where this H basically means Hermitian operation. Hermitian means we take complex conjugate transpose. We do the transpose, take the conjugate. That's it. And some useful quantity here. This Wn e raised to j 2 pi by n. This Wn raised to k is same as Wn raised to k plus n for any n. This is easy to see. Why is that so? Wn raised to k plus n is what? Wn raised to k times Wn raised to n. And Wn raised to n is what? E raised to j 2 pi by n times n, which is what? So this is the one property that is interesting. Wn raised to k is same as Wn raised to k plus n. This is also related to the previous property, but we just write it separately. So Wn raised to minus k is same as Wn raised to n minus k. So same as this. The only thing is that we change k to minus k. two properties which are very useful, and we'll be using this in solving problems. So to summarize, we have expressed the operation of DFT and IDFT as matrix multiplications. So we have DFT to be f times x, whereas IDF to be 1 by n f Hermitian x. In textbooks, there might be a different notation. Some of them call f Hermitian as f and so on. So the thing to note is that if we call this as f, then we should use f Hermitian for the inverse DFT. That's it. So, sorry, I'm so sorry. Okay, so any doubts or any clarifications? If everything is fine, we can proceed to the problems. F Hermitian is basically this is Hermitian basically. Yeah. Hermitian means it's like this. So if I have an matrix like let's say A equal to 1 minus j 2 plus 3j 3, what is a Hermitian? So how do we do that? We do A conjugate transpose. What is it? This is like this is the Hermitian. Sorry. Yeah, thanks. So I'm sorry, actually I'm having some cough, so I might cough in between. Please excuse me for that. Okay, so any other doubts or clarifications? Shall we proceed to the questions?
Yes, sir. Proceed.
Okay, thanks. Few more terms in F matrix. What happened? What should I do here? Yeah. So that one, fine. Let's see. So if we see this, second row will be like this. Second row we have seen, this is Wn1 up to Wn n minus 1. Third row will be Wn. First, of course, this will be 1 to n minus 1. So k comma n will be Wn minus k minus 1 n minus 1. I think, yeah, this is a general term. Is that okay? Okay. So we'll move to the question. Okay, so this is the first question. This appeared in I think 2015 or 16, around that time. I don't exactly remember. But yeah, this was asked in one of the past GATE exams. So the question is like this. This is an interesting question. So there are multiple ways to solve this, but let us see what the question is. So two sequences ABC and capital ABC are related like this. We have capital ABC to be a matrix times a vector. What is a matrix? 1 W3 inverse W3 minus 2, 1 W3 minus 2, W3 minus 4. Now here it is given that W3 is e raised to j 2 pi by 3. That's it. Nothing else is mentioned. Like it didn't, nowhere in the question it is mentioned that it is DFT, or is it like something else, or is it even signals and systems? Nowhere it is mentioned. So only thing given is that there are two sequences ABC and capital ABC, and this is how they are related. Now what the question is, if another sequence PQR is derived like this, we have PQR to be some matrix times some other matrix times A by 3, B by 3, C by 3. Then we need to find what is the relation between PQR and the actual sequence ABC. Is the question okay? Question is relatively straightforward. I mean, everything is there, like given the relation between ABC and small ABC. Sorry, we need to find what is the relation between PQR, which is defined like this, and potential ABC. That's the question, and we are given with 4 options. So is the question fine? Question is okay, no? Is there any clarification in the question? Okay. So how do we solve this? Straightforward way is like this. It is given that ABC is related to small ABC through this relation. So what we can, it is also given that PQR is related to capital ABC like this. PQR to be some matrix, some other matrix, A by 3, B by 3, C by 3. What we can do? Substitute this guy in terms of this guy. So what do we have? PQR to be one matrix, another matrix, and then A by 3, B by 3, C by 3. So there is a 1 by 3 common here. I'm just pulling it out. Sorry. So there's a 1 by 3 common here. I'm just pulling it out, writing it here. I have PQR to be 1 by 3 times some matrix times another matrix times one more matrix times ABC. So what is the question? We need to find the relation between PQR and ABC. So what should we do? We basically need to multiply these three matrices. There will be some simplification happening on, and then see what is the relation. That's it. So the question is clear now. What we need to do is also clear, right? Up to here, it's clear now. We just use the fact, whatever is given in the question, to get the relation between ABC and PQR. To answer this question, we need to do this, evaluate this part. That's it. So up to here, is everything fine? Okay. Now, in this question, we can do that actually, because all these matrices are 3 cross 3. So multiplying these matrices won't take that much time. So multiplying these matrices won't take that much time. But still, there is an easier way to solve this question if we know the properties of DFT. So how is that? Let us see. So if at any point of time, if you're not able to follow, please let me know, interrupt and let me know. So slightly interesting. So we have ABC and we have this matrix. So what is this matrix? This is the DFT matrix, no? This is DFT matrix of dimension 3 cross 3. Is that fine for everyone? Is that fine for everyone? It is not given in the question, but it is a DFT matrix. Just now we have seen how we define DFT matrix. So this guy is the DFT matrix. Is that fine for everyone? Is that okay? Okay. Similarly, if we see here, this matrix is basically, this entire matrix is Hermitian of this matrix. It's easy to see. We take the transpose and put the conjugate. So what is this? This is the IDFT matrix F Hermitian. Is this fine? This fine for everyone? This guy is the inverse DFT matrix, and this guy is the DFT matrix. It's not given in the question, but from theory, we know that is the case. Is that okay? Okay. Now, what are we asked to find? We need to find what is the relation between ABC and PQR. So in this question, this PQR, if you see like this, IDFT matrix, and this is the usual scaling 1 by 3, so 1 by n. Now if we see what is PQR, PQR is basically the inverse DFT of this much part. Does everybody follow that? PQR is IDFT of this entire thing, whatever we have in this shade part. Is that okay for everyone? This fact we can quickly solve this problem. That's what I was about to. That's what I'm trying to solve. To summarize, what do we have? PQR is basically IDFT of whatever is here. Is that okay? Any questions? Shall I proceed? Okay, thanks. Now, let us recall this property. If x1n circular convolution x2n in time domain, in frequency domain, that will be x1k times x2k. See here, to answer this question, what we need to do is we need to find what is the IDFT of Z of k. It might feel that we are complicating things further. Okay, what is this? So what is this Jamboard thing? What is this? Can you say something about that? Okay, maybe we'll discuss at the end. So to solve this question, we need to find the IDFT of Z of k. It might feel that we are complicating things further, but not really. It is very simple. Like once we realize this is the case, solution is very simple. It's much simpler than multiplying these three matrices that I can tell. So what do we have? We need to find the IDFT of this much part. If we see here, this much is nothing but ABC, capital ABC. This much is ABC given in the question. Now, this is a diagonal matrix. Now, if we do this thing, let us say 1 0 0 0 W3 square 0 0 0 W3 4 times ABC. What are we getting? It will be A W3 square B W3 power 4. This is also fine, no? I am multiplying a diagonal matrix with a vector. That means I am multiplying the first entry with this guy, and third entry with this guy. That's it. So this entire thing inside hello, I'm still there, right? So what I'm telling is that this entire thing in this red bracket is nothing but something like this. I have two sequences ABC and one omega. So the entire thing in this red bracket equal to x1n x1k times x2k, where x1k is basically our 1w2 cube w2 power 4, and x2k is basically ABC. Is everyone fine with this fact? If something is confusing, please let me know. Up to here, is it okay? What I'm saying is everything in this bracket, this can be simplified to be like this: A W3 square times B W3 power 4 times C, and that is nothing but product of two sequences, where first sequence is 1 W2 cube W3 cube W3 square actually. Yeah. So what I have instead of k is basically x1k times x2k, where x1k is this guy and x2k is this guy. Is everything fine till now? If it is fine, then we are we got the answer mostly. So is everything okay till now? Okay. So now we have this property. Multiplication frequency domain means circular convolution time domain. Consider this signal 0, 1, 0. Consider this one. What will be the Fourier transform? X1k will be summation 0 to 2 x1n w3 raised to minus kn, which is w3 minus k, which is 1 w3 inverse and w3 minus 2. Now, we have this property wn k is same as wn k plus n. Therefore, this guy we can write like this. W3 raised to minus 1 is same as W3 raised to 3 minus 1, which is W3 square. Similarly, W3 raised to minus 2 is W3 raised to minus 2 plus 3, which is W3 raised to 1, which is also same as W3 raised to 1 plus 3, which is W3 raised to 4. For this signal, 0, 1, 0, DFT is this thing. Is that okay? Shall I proceed? Okay. So, putting it all together, PQR is IDFT of Z of k. Now, Z of k is like this, which is x1k into x2k, which is DFT of x1 and circular convolution x2n, where x1k is 1 w3 square w3 power 4 and x2k is ABC. Corresponding signals in time domain x1n is 0, 1, 0 and a small abc. So what? PQR is IDFT of Z of k, which is IDFT of DFT of this quantity, which means this quantity itself. So PQR is basically circular convolution of this sequence with ABC. That's the thing. So up to here is everything fine? We just use the properties and simplified the problem to be like this. PQR is circular convolution of x1n with x2n, where x1n is this quantity and x2n is ABC. That's it. We didn't do any hardcore matrix multiplication, anything like that. Just using the properties, we simplify the problem to be that of evaluating circular convolution between these two sequences. Any doubts till now? How is x2 x2 and ABC? Yeah. So what I want to compute is this. So Z of k is some matrix times some other matrix times ABC. Now this is the DFT matrix. This is the sequence in the time domain given in the question. So what I'm trying to see is I'm trying to write this also as a DFT of some other signal. If I can do that, then that means multiplication the frequency domain. That's it. This are you able to follow? This one? Is it okay up to here? Yeah.
Uh,
So yes.
no, that is multiplication, right? Why we are writing how that multiplication results as z of k?
Which one?
The z of k equal to x1k into
Yeah.
x2 of k. But why we have
Hmm.
written x1 of k and x2 of k as this means its multiplication matrix multiplication cannot be done, right?
No, no, no. This is not matrix multiplication. What I'm trying to see is this is a discrete time sequence. This sequence is obtained by taking the product of this sequence and this sequence. Okay, maybe I should use normal brackets. These are just two sequences, not the vectors. So what I'm trying to see is that I'm trying to relate the matrix representation of DFT with what we have in the usual sense. So what I'm saying is this set of k is a discrete time sequence of which the kth entry is given by product of the kth entry of this sequence and kth entry of this sequence. That's it. Is that okay?
Ah, okay.
Okay. And the other question, so yeah, so are you able to follow up to here? X1k and X2k as these two things.
Yes.
Okay. So since this is the thing, so 1 omega 2 square omega 3 sorry w2 square w3 power 4, the signal in time domain happens to be 0 1 0. This is also fine, no?
Yes.
Now this one, capital ABC, from the question, DFT of small ABC.
Okay, sir, got it.
Okay, fine, fine. Thanks. So what do we have? We have basically the problem of interest is simplified to that of just evaluating the circular convolution of these two sequences. That's the thing. So we will evaluate it now, but before that, any other questions? Shall I proceed? Might seem a bit too long, but once you know the right properties, these things can be done pretty fast because we don't have to do any numerical here, just evaluating fast. Shall we proceed? Any other questions? Okay, I think it is fine. So what do we have? I need to find the circular convolution between these two things. So how do we define that? X1 circular convolution with X2 is defined like summation k equal to 0 to X1k X2 of n minus k mod 3. This is the circular shifting. In the beginning of the class. Okay, so what is this X1k? Sorry, yeah, this k is sorry. This is not the DFT. Everything is happening in the time domain. I just happened to. I happen to use k. I can use some m or something to avoid confusion. Okay, so here it is 0 1 0. That means this is nothing but x2 of n minus 1 mod 3. So the answer is circularly shifted version of x2 by 1 unit. Now it is easy to see p. P is the first term basically. PQR. P is the first term. That means substitute n equal to 0 in this expression. What do we have? P to be x2 of minus 1 circular shifted version, which is nothing but, so if you remember the example 1 2 3, if we circular shift, 3 will come here, 1 will come here, 2 will come here, the earlier example. So what happens? P will be x2 of minus 1 3, which is x2 of 3 minus 1, which is C, the last entry. Then Q will be A and R will be B. Once again, for simple thing only, I have ABC circularly A, have B, and C will come back. That's it. So I just shift it to the right. So A becomes here, B becomes here, C becomes here, but come back here. So the answer is PQR is same as CAB. Is that fine? Any doubts? Is everything okay? Another way to do this multiplication, like, and this is not an easy thing because there will be so many terms and many properties like W n raised to k plus n to be W n raised to k and so on to simplify the entire thing into a nice form. Otherwise, you won't get a good answer. Because if you multiply these three matrices, there will be so many entries. It will be hard to follow. So instead of doing this direct multiplication, we can use the properties and solve the problem like this. Now, if you're seeing this for the first time, this will be a bit tricky, but with practice, this will come very fast. From this expression itself, it is very clear that this is IDFT, and I'm working with something of whatever is here. Now, whatever is here means I have ABC times some other sequence 1 W3 square and W3 power 4. The only potential place where we need more time, we might not know what is the time domain signal for this DFT. But it's again, with a bit of practice, you will be realizing that 0 and 0 will be the time domain signal corresponding to this x1k. That will come with practice. So once we know these two facts, problem is mostly solved because it simplifies to that of just okay. So any doubts in this question? If not, we can move to the next one. When you see for first time, you might feel this is difficult, but this is much simpler than actually computing those matrix multiplications in during the actual exam. So any doubts? Shall we move to the next question? Okay. Okay, so next question is like this. This came in 2016 S2. So the question is like this. The discrete Fourier transform DFT of the 4-point sequence xn, which is like 3, 2, 3, 4. This is given by 12, 2j, 0, and minus 2j. If x1k is the DFT of the 12-point sequence, which we get like this, then what is the value of x1 by x1 of 11? Now, what is x1n? X1n basically means we have our x of n and add 2 zeros between every non-zero value. So what we have? We have 3, then put 2 zeros, then we have 2, 2 more zeros, we have 3, 2 more zeros, we have 4, and 2 more zeros. So the question is, I guess, given x of k, we need to find what is x1 of k. Specifically, we need to find what is this ratio. That's what we need to find. Is the question fine? Sorry. Question is fine, no? Shall we move to the solution? Once again. Not audible actually. Hello?
So is that to find x1 of k, or I didn't understand that 3 comma double zero or 2 comma double zero.
So we are defining a new sequence. A new sequence which is obtained by adding 2 zeros after every non-zero value in the actual sequence. So 3, 2, 3, 4 is my actual sequence. Now I construct a new sequence by adding 2 zeros. 3, then 0, 0, then 2, 0, 0, 3, 0, 0, and 4, 0, 0. I am defining it like that. Sorry. Is that okay?
Okay, sir.
Okay. So I have a sequence here. I define a new sequence here. The DFT of the original sequence, DFT of the original sequence is this x of k. We need to find what is the DFT of the new sequence. That's it. And then find the value of this ratio. So what do we have? We have x of k, x of n e raised to minus j 2 pi by n k. That is fine. So what is the relation between x of n? So we can write x1n to be x of n by 3, which I define like that. This is same as x of n by 3, where Okay, this might look a bit weird, but yeah, where 3 is an integer, 0 otherwise. So let us call it like this. Let us call x for n to be x of n by 3, where by 3, what I am denoting is wherever this n by 3 is an integer, then the value of this x for n will be same as signal at n by 3 and 0 otherwise. What I mean is that x1 of 0 will be x of 0 by 3. This is happen to be an integer. This is nothing but 3. Now x1 of 1 will be x of 1 by 3. This is not an integer, so it is 0. Similarly, x1 of 2 will be x of 2 by 3, not an integer. This will be 0. Finally, x1 of 3 will be x of 3 by 3, which is x of 1, which is equal to 2. That's it. So, is this definition fine? Shall I continue?
Yes.
Okay. So, what do we have? We need to find what is the Fourier DFT of x1. So, this is the DFT. Now, what do we have? Using the same notation 0 to 11, x of n by 3, with the understanding that x of n by 3 means this thing. That is implicit. We are not writing explicitly, but with this understanding, this is how we define the quantity. We can write like this: e raised to minus j 2 pi by, we have a 12 here. I'm going to write like 2 pi by 4 into n by 3 into k. This is fine, no? I just substituted for x1 n like x of n by 3, and this 12 I have written as 12 as 4 into 3, and x1 n as x of n by 3. That's it. Note that k goes from 0, 1 up to 11. That's the thing. What we can do a change of variables. Sorry. We can do a change of variables. What happens? Put n by 3 equal to m. N equal to 0 means m equal to 0. And n equal to 11 means I can write m equal to 4 minus 1. How do I get that? I noted like this: 12 minus 1 by 3. 1 by 3. Something like that. No. Wait. That will complicate things further. Yeah, this is not that difficult. So, yeah, it goes 0 to. Okay, let us write it and see. That's easier. So, if I call this as m, then n goes from 0 to 11. M goes from 0 to 3. Only 3. 4 won't come because m equal to 4 means n equal to 12. So, one more thing that we need to note here is that only when this is an integer, that term is having non-zero value. Wherever this n by 3 is not an integer, this quantity itself is 0. So, we don't have to worry about that. So, we only need to add terms where this is an integer. That's right, no? Summation n such that n by 3 is an integer This means summation m equal to 0 to 3 x of m e raised to minus j 2 pi by 4 mn. Is that fine? Is simplification fine? If something is please clear, not clear, yeah. Uh, no means is it clear? No, or any doubts? No. Shall I
It's
proceed?
clear, sir. Yes, sir.
Okay, thanks. So we have x1k to be this thing. What it means is that the expression here. Okay, by the way, it should be k, not n. That's fine. Yeah. So what it means is that DFT of x1k is same as the actual DFT. This is actual DFT. 0 to 3 x of m e raised to minus j 2 pi by 4 km. Actual DFT, but it is repeating 3 times. So what it means, I have, so k is going from 0 to 11. Earlier, k was from 0 to 3. Yeah. Now, if you see this, it's easy to see that e raised to minus j 2 pi by 4 m k plus 4 is same as e raised to minus j 2 pi by 4 k. This is the periodicity property. This is same as writing w4 raised to k plus n is w4 raised to k, where n equal to 4. What it means is that x1 0 will be x of 0, x1 1 will be x of 1. How am I writing this? I have x1k to be like this. I'm just substituting k equal to 0, 1, 2, 3 and all here. That's it. So x of 2, x1 2 will be x of 2, and x1 of 3 will be x of 3. Now what happens? x1 of 4 will be substituting k equal to 4 here. That turns out to be same as x of 0. Is that fine? x1 of 4 is again x of 0 because of the periodicity. Then x1 of 5 will be x of 1 and so on. Is that fine? Shall I proceed?
Yes, sir.
Okay. So what do we have? In the question, we are asked to find the ratio x1 8 by x1 11. So what are these things? x1 8 will be x of 0. It's C7, 8 will be here only. And x1 11 will be like, this is like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Last step, that will be x of 3. X of 0 is what? So 12, given the question. And x of 3 is minus 2j. Therefore, modulus of x1 8 by x1 11 is modulus of 6. Is it okay?
Sir.
Okay. So the key takeaway point here is that wherever we have a case actual signal and we add zeros in between, the DFT will repeat that many times. For example, if we add two zeros in between, the DFT of the new sequence will be DFT of the original sequence again, DFT of original sequence, one more time DFT of original sequence. So it will come three times. If we add two zeros, DFT of x1 n will be original DFT repeating three times. That's idea. If we add L minus 1 zeros, zeros in between each non-zero values. Zeros in between. Then x1 of k will be x of k up again repeating L times. So if this property is known, then we can directly solve this question by looking at the value. x18 will be this one and x19 will be this one. So yeah, so that's the solution. So any doubts or clarification here? Is it okay?
Yes, sir.
Okay. So I think it's already 8 o'clock. So I'm not planning to take more because can you explain n by 3 part? Yeah. So I just returned like, by the way, so I'm not planning to take any new topic right now. So if anybody want to uh, like it's already 8, so I'm not asking everybody to stay here. That's not right. So I'm not planning to cover any new session. If you want to be in the session, please be here. Otherwise, you may leave. We can meet next week. Next week the topic will be again related to
Sir, can you please scroll down the page?
yeah. Will there be a recording of the session? I'm not very sure about that. I have a recording with me, but I'm not sure will it be made available. That we need to see. Okay. Yeah. Yeah. What was the question? By the way, if anybody is having any doubt or any suggestions or any feedback, please reach out to me. My mail ID is there in the messages. Okay. So what was the question?
So n by 3 part.
Okay. Yeah. Sure. I think one more question. I'll come to the other question. Let me first see this. Okay. And by so, are you able to follow this one?
Yes,
I'm
sir.
just
Yes, sir.
wherever n by 3 is an integer, I take the value at that point x of n by 3, and wherever it is not an integer, I will be defining that value as 0. That's it. Is it okay?
So next page, from next page.
Yeah.
So this x1k is equal to summation of n is equal to 0 to 11.
Okay.
This
Yeah.
part I'm not getting it.
So this is the DFT definition. This slide is fine, no?
So after this,
Yeah. After this, I just with the understanding that wherever it is not an integer, we'll be having 0 as a value. Is it okay?
so how did you replace n that is written e to the power minus
Yeah.
2 pi by 12 k
Huh?
n, and the
Yeah.
next line you have written 2 pi by 4 into n by 3 into k.
Yeah. Yeah. So
Why are you not
yeah,
uh, like
we have 2 pi by 12,
replace
right?
n by 3
Once
or
again.
like n by 3. You have
No, no, I did
replaced
not
that.
replace anything. I just substituted for x1n as x of n by 3. I did not substitute. I just replaced. X1n is x of n by 3. That is okay. This
Yes,
is same as this. That is okay, no?
yes,
This is same as this. That is fine, right? Now, what we have here, I did not change anything. This 2 pi by 12, I written like 2 pi by 4 into 3. That is same. 12 is 4 into 3. So, here, this 4 into 3, I have just written that as n by 3. So that both of these are n by 3. That's it. Did not do any substitution there.
okay, okay, okay.
Okay.
Next.
Then, let me tell this line before going. That is better. So, the thing is that even though we have 12 terms, only 4 of them are non-zero. Why is that so? Because if you see here, x1n is x of n by 3, which will be non-zero only when this is an integer. Otherwise, this is 0. So whether or not those terms are there doesn't really matter. Correct, no?
Yes, sir.
So what I have x1k to be summation over all n such that n by 3 is an integer. I just written that in English. That's it. Summation over all n such that n by 3 is an integer. This I just kept the same. No change here. X of n by 3, e raised to minus a 2 pi by 4 n by 3 times k. That's it. Is that okay?
Okay, sir.
Okay. Then, now if you see here, for what all values this will be integer, n equal to 0, n equal to 4, n equal to 8. That's it. That's it. No? n equal to 12 won't come here. So, for these values, it is not 0. So, I just replace it like this. Sorry, not 4. I mean, n equal to 0, 3,
Yes, sir.
6,
Yes, sir.
9.
Now I got it.
This one. Yeah, fine. That's it.
Okay, sir.
That's it. And then just routine work. That's it. Okay. Okay, no?
Okay, sir.
Okay. So next week again, this will be like some more questions are there on this. After that, we can any other general suggestion like is the approach fine or should I change anything? Mostly I'll be starting with some basic theory, some definitions, and then I'll be moving to questions. And also, close to the gate exam, like after like some 4 weeks or so, to just do revision. Revision in the sense that won't be covering much of theory, but more questions. That's what I'm thinking currently. So, if there is any feedback or anything that you would like to convey to me, please let me know. Please mail on my ID. That'll be fine. Is everything fine? Shall we pause for the day? If there is any feedback, feel free to let me know. So, shall we pause?
Yes.
Okay. Okay then. Thanks. We'll meet next week. Thank you very much. Okay. Thank you.